This is lesson 4.3, and we will be writing and solving addition and subtraction equations. This will be very similar to when we were writing expressions, but now we will be solving for the variable. So let's look at this solve and discuss. The directions say a group of students were on a school bus. How many students were on the bus before the last stop? So look at this first sentence. That's very important. A group of students were on a school bus. Are they telling us exactly how many students are on the bus? Or they're just saying a group. So that can be any unknown amount. We should keep that in mind because we might have to represent that unknown amount with a variable. So there's a group of students on a school bus. Then at the last stop, the bus picked up 16 students. The bus arrived at school with 25 students. So let's think about this. There were a group of students on the bus. We don't know how many students were on the bus. So we're going to represent that group of students with S. Then we can say at the last stop, the bus picked up 16 students. That means 16 more students will be getting on the bus. If 16 more students are getting on the bus, do you think we will be adding 16 or subtracting 16? We will be adding 16 because 16 more students are joining those S students that are on the bus. Then it says the bus arrived at school with 25 students. So there will be 25 total students on the bus. That is what we're going to set this equation equal to. So we will have S plus 16 is equal to 25 students. Now, let's maybe just draw a little bar model here to see if this makes sense. There were a group of students on the bus. I called that group of students S. Then we said 16 more students got on the bus, and by the time they got to school, there were 25 students on the bus. So now we want to solve for S. We will have S plus 16 equals the 25. So now when I solve equations, I like to draw a dotted line down the middle because I'm going to keep the left side of the equation different from the right side of the equation. So right here I have S plus 16 equals 25. My goal is to get that S alone. I want S to be alone on one side of the equation. So right now, what is with that S? Plus 16 is with the S. So how do I get rid of plus 16? What is the opposite operation of addition? The opposite of addition is subtraction. Because if I have plus 16 and then I subtract 16, well, 16 minus 16 is 0. That leaves me with just S on the left. But if I'm subtracting 16 on the left, I also have to subtract 16 on the right. So I always say to my head, whatever I do to the left, I have to do to the right. Whatever I do to one side, I have to do to the other side. So now I'm going to solve this equation. What's remaining on the left side? On the left side of my equal sign, I only have an S. Let's bring that down. So now I'm saying S is equal to, well, what's on the right side of my equal sign? On the right side of my equation, I have 25 minus 16. What's 25 minus 16? 9. So let's see if this makes sense. A group of students were on the bus. Well, how many students were on the bus? 9. Let's replace this S down here with 9. If I have 9 students on the bus, Then 16 more students join. Okay, well, 9 plus 16 equals 25. So this equation makes sense. Okay, now let's look at example 1 here. Example 1 says George has some plastic figures. Anytime you see some, that's just some amount. S-O-M-E, some. Some amount of plastic figures. That's an amount that we don't know. After he bought 7 more figures, he had 25. How many plastic figures did George have before he bought more? So he had some amount of plastic figures, he bought 7 more, then he had 25. Well, let's picture us going to the store. We buy some amount of plastic figures. I represented that some amount of plastic figures, that amount that I don't know, with S. I could have used any variable because a variable is an unknown amount. After he bought 7 more figures, okay, 7 more, should that be addition or subtraction? 7 more would be addition. So I have some amount of figures. I buy 7 more. Then I have 25. So again, I have S plus 7 equals 25. Okay, I have to keep my equation balanced. So I'm going to keep my left side of my equation balanced with my right side of my equation. Well, my goal is to get this S alone. Right now, what is attached to the S? Right now, a plus 7 is attached to the S. In order to get rid of that plus 7, I have to do the opposite operation of addition. What is the opposite operation of addition? Subtraction. So instead of plus 7, I'm going to have to minus 7. Whatever I do to one side, I have to do to the other side. That's what keeps my equation balanced. Well, if I have plus 7, minus 7, 7 minus 7 is 0. So I'm going to cross that off. All that remains on the left side of my equation is an S. And now let's solve the right side of the equation. 25 minus 7 is 18. So that means that George had 18 figures before he went to the store. So let's look at some of these graphics here. One way we could solve this, it says, one way you can find the value of n is by getting it alone on one side of the equation. So that's what we did actually. We took 7 away from both sides, right? We had a number plus 7 equals 25. We took 7 away on the left and 7 away on the right. That gave us the unknown value for S. So S equals 18. They just represented their unknown value with the letter N. Another way would be to draw a bar model. To solve the equation, you find the value of n that makes the equation true. So n plus 7 equals 25. What's that unknown value? It would be the 18. And then this last one is the way that we did to solve the equation. We subtracted 7 from both sides, and then we got the 18. So now in your notebook, I want you to write number 6. Number 6 says 12 is equal to y minus 11. Okay, so here we have our equation. Now the variable is just on the right side of the equation, but we are going to do the same thing. We are going to get that variable alone. Well, what's the variable here? The variable is the y. How do we get that y alone? Well, what's attached to the y right now? Attached to the y right now is a minus 11. What's the inverse operation or the opposite operation of subtraction? The opposite operation of subtraction is addition. So I'm going to add 11 to the right side of the equation because minus 11 and plus 11 will cancel out and equal 0. That will leave me with just a y on the right side of the equation. But my equation isn't balanced because if I added 11 to the right, I must add 11 to the left. Now my equation is balanced. So I have y equals, well, let's solve that left side of the equation. 12 plus 11 is 33. Okay, next I want you to solve let's try number 8. So what will t equal if the equation is t minus 40 equals 3? Solve this. So my equation, t minus 40 equals 3. I'm going to have to get that t alone. So, and how do I get the t alone? I'm going to add 40 to both sides. That will leave me with t equals 43. Last one I want us to look at before we look at some word problems is number 7. So rewrite number 7 in your notebook. 22 is equal to 13 plus a. Wait a second. This 13 doesn't have a sign there. Do you think that 13 is a positive 13 or a negative 13? If there's no sign there, it's going to be a positive 13, just like this 22 is a positive 22. Okay, so now solve for a. How do you get a alone? What does a equal? So, in order to get a alone, I have to get rid of that plus 13. I want to get 0 with the a. So instead of plus 13, I'm going to do minus 13. Whatever I do to one side, I have to do to the other side. So that leaves me with a alone on the right. 22 minus 13 is 9. A will equal 9. So these were just some practice questions to see how we would solve equations, even if the variable's on the other side of the equation. Lastly, I want us to look at number 4 here, a word problem. The outside temperature dropped 20 degrees from the time Ariana ate breakfast until the time she ate dinner. When she ate dinner, the temperature was 35 degrees Fahrenheit. Write and solve an equation to find the outside temperature when Ariana ate breakfast. Okay, so the outside temperature dropped 40 degrees. If something is dropping 40 degrees, do you think we will be adding or subtracting? If something drops, we will definitely be subtracting. Okay, so I have an outside temperature in the morning. Do I know what that temperature is? No, I don't. So it's going to be an unknown value t. But then what happens to that outdoor temperature? The outdoor temperature in the morning is going to drop 20 degrees. So I will have t minus 20. I got the t because I just chose any variable, any unknown amount. So I have t minus 20. Then when she eats dinner, it's 35 degrees Fahrenheit. So we will have t minus 20 is equal to 35. So now solve this equation. What was the temperature when Ariana ate breakfast? You should have gotten 55 because I'm going to try to get t alone. I want to solve for t, so I have to add 20 to both sides. I want to get rid of that minus 20. So I will add 20 to both sides. Minus 20, positive 20 cancel out. That leaves me with t equal to 35 plus 20 is 55. Well, now let's see if that makes sense. Let's go back to the word problem. The outside temperature dropped 20 degrees from the time Ariana ate breakfast. So she ate breakfast and it was 55 degrees. Then it dropped 20 degrees It got 20 degrees cooler. And then when she ate dinner, the temperature was 35 degrees Fahrenheit.